Okay, 6.4 part 1. These are, we just did in 1.6 part 2, exponent properties and rules. This is basically taking that one step further. We're going to take what's called rational exponent properties, and whenever we use whenever you see that word rational, you know that that's going to be a fraction. Okay, so we're looking at fractional exponent properties, but the rules apply the same way. Instead of a whole number, we're just going to be using fractions, hence the name rational exponents. So the property where we had the same base and we're multiplying them, if you remember, we just added the exponents. For instance, if I had 5 to the 1/2, again, now we're dealing with fractional exponents, times 5 to the 3/2, you would go ahead and add 1/2 plus 3/2. Now, you could be doing this in a calculator. In fact, when you get into some of the more difficult problems, probably are going to go and use your calculator to add fractions. But please remember that on the SATs or other standardized tests, also even the military tests, take away the calculator for a good number of these problems. So you must be, I know, going to be a little rusty with adding fractions, but remember, you can only add and subtract fractions when you have the common denominator. Now this one's not that bad because we already have the common denominator too. So when you add 1/2 and 3/2, you have 4/2. So we have 5 to the 4/2, which is 2, 5 squared, which is 25. Now, when you have numbers, you're going to have to multiply it all the way out to get your answer. We're going to be dealing with numeric and algebraic rational expressions. So you're going to have to do, simplify it as much as you can when we get to the algebraics. All right, second one. When we have a number outside of the parentheses, an exponent outside of the parentheses, don't forget, you have to think of it as distributive. But in reality, since we only have one term in here, we're just multiplying the exponents. Okay. For instance, if I have 3 to the 5/2 raised to the 2, now don't forget that 2 is over 1. So when you multiply fractions, you just multiply straight across. It would be very helpful if you cancel out any factors, top and bottom, first, to save yourself some reduction or simplifying later. So I have 3 to the 5 over 1, which is 3/5, which is 243. When we have two terms, this is really when you have to distribute. Because you have more than one term here. You're actually distributing here, but it ends up being multiplication of one term. So I'm going to distribute the a to the exponent. Remember, if there's nothing there, there's a 1 to each one of these. For instance, if I have 16 times 9, I would distribute, again, there's exponents there, 1/2 to each of those. And I have 16 to the 1/2 times 9 to the 1/2. Now, we're going to get into radicants a little later, but I know that anything raised to the 1/2 is actually the square root. It's the same thing as square rooting it. So we're going to square root 16 to get 4, square root 9 to get 3. 4 times 3 is 12. And when I have negative exponents, this is where you have to move that power, either if it's in the numerator, then you move it to the denominator. So we're going to move. I'm going to call this move. Or if it's in the denominator, say that was a negative a, then I would move it into the numerator and make it positive. Now, I like using the word flip because when we get into especially rational exponents, don't forget we're dealing with a fraction already because we are already putting that whole number over 1. And then, so now we end up with, well, now we got a fraction here and a fraction here. And when we say move the fraction, well, then it starts getting confusing. So I like saying flip. It kind of just, I can put it towards what I um, easily say what I mean here by flipping the negative 1/2 makes more sense than, hey, I'm going to move 36 to the 1/2. I'm going to flip the 36 or move the 36 and the 1. So I just like saying flip the negative 1/2, 36 to the 1/2. So I move that whole term to the bottom. And again, that 1/2 represents a square root. So I have to reduce to 1/6. Next is the same base in a subtraction or division to fraction. So I subtract the exponents, just like we did with numbers. Again, be careful. Make sure you have the same denominator. Otherwise, you're going to have to change and find the lowest common denominator or a common denominator. 5/2 minus 1/2 is 4/2 or 2. 4 squared is 16. Now, when I have different bases, it becomes a little, you still subtract, you actually, if it's a number, you're just going to simplify. So when you have different bases raised to a power, don't forget you distribute to each one. So I have, so again, let's say distribute. Distribute or multiply, that's fine. I like distribute for this one because it's got two different terms. So I'm going to take, for example, 27/64 to the 1/3. And 27, they're being nice here, 27 and 64 is a perfect cube. Again, that 1/3 isn't a square root, it's a cube root. So the cube root of 27 is 3. The cube root of 64 is 4. Also, don't forget, anything raised to the 0 power is going to be 1. Okay. It's actually multiplication, but I'm not going to worry about it because it's a 0 power. So let's do some examples. Number 8. Let's see, I have the same base. I'm going to add the exponents. My exponents for this is 5/2 plus 1/2. That gives me 6/2, which reduces to 3. So this becomes x to the 3rd. Number 9, don't forget there's a 1 there. So I have to distribute at 1/4. So now I get 3 to the 1/4 times x to the, now I'm going to do this down here, 5/2 times 1/4. Check to see if you can cancel out any factors, top to bottom. This one you can't. 5 times 1 is 5. Because it's multiplication, I don't need a common denominator. 2 times 4 is 8. So I have x to the 5/8. That's it. That's as far as we can go. Okay, number 10. Now, as we learned in the 1.6 part B, when we did that exercise last week where we did solve this in many different ways, or you were supposed to come up with two ways to do some of these problems. One of those ways was, hey, let's do this fraction, then we'll do this fraction, the same basis, right? Or same type of basis. These are numbers. These are x's. So, and then we have our y's. Okay. Now, this is where you guys will probably start to pick up your calculators. Me too, because these are not easy. So I'm going to simplify. If you put in your calculator, 12 divided by 8, hit enter, math, enter, enter, you're going to get a fraction. Or you can start, again, I know you're a little rusty with fractions, but start using, going back to your brains and start using that, and it will get easier. Okay, so 4 goes in the 12 is a common factor for both of those. So 4 goes in the 12, 3, 4 goes in the 8, 2. For the x's, I have 5, 6. I'm subtracting because it's division, 2/3. My common denominator here is going to be 6. So I have 5, 6. And I need to multiply that 3 by 2 to get 6, which means I have to multiply the 2 by 2. So I get, oops, that should be minus 6. 2 times 2 is 4. My common denominator is 6. 5 minus 4 is 1. So I have x to the 1/6. And then the y, let's see, y I'll even do on top of that. 7/3 minus 2/5. On this one, the lowest common denominator is going to happen to be 3 times 5. Sometimes you could just multiply the denominators together and get the lowest term. Or you can get a common denominator, but you just have an extra step here of simplifying. So I'm going to have 15. So I'm going to get 15 minus a 15. Let's see, I'm going to multiply this fraction by 5/5 and this fraction by 3/3. And I'm going to have 7 times 5 is 35. 2 times 3 is 6. 35 minus 6 is 29. So and it's positive, so the y is going to be a numerator to the 29/15. Now that's pretty ugly, but it's our answer. Again, I expect you guys, if you do have a calculator, if they allow you on a test or something, go for it. Use it. Certainly is going to be easier. Okay, so if I had, let's do the y's just for example. 7/3, 7 divided by 3. Please put them in parentheses. Minus 2/5, 2 divided by 5. Enter. Then your math. Enter, enter, and you get your 29/15. Okay, number 12. Well, this is nice because remember, anything raised to the 0 power, even if you have two terms, many terms, as long as it's parentheses, 0 outside, that is going to equal 1. Then I have my x to the third, 1/3. Remember, this all equals 1. And then my x to the -5/2. So I'm going to take, I should have did this out here. So I'm going to take my 1/3. I thought that was a lie. So I'm going to 1/3 multiplying it. So I'm going to add a -5/2. Again, you can put it in your calculator. So I'm going to have, let's see, common denominator is a 6. Instead of a plus negative, I'm just going to put a minus a 6th. See, I'm multiplying by 2. Got to multiply that by 2. So I have 2 6. I get 3 and 3. So I have 15. 2 minus 15. It's going to be a -13/6. Another nice fraction. And actually, because it's a negative, I'm going to put my x up on top, and I'm going to change it to a +13/6. There's my answer. And then the last one. Again, we learned it's easier to do our work inside parentheses first. So I have my x to the 3/2. 3 minus 1 is 2. It's positive. I'm going to put that raised to the 1/4. I didn't need to make this a fraction. Then I'm going to distribute 1/4 to each of them. I'm not going to worry about the 1 because it's not going to be a fraction. And I get x to the 3 times 1 is 3. 2 times 4 is 8. Don't need to reduce that. Now, when I multiply this 2, or 2 over 1 times 1/4, cancel out a factor of 2, and I get 1/2. And there's my answer. And that's it for the first part of 6.4. Second part, we're going to get into more algebraic rational exponents.